Alright, in this video we're going to take a look at things called electron filling diagrams. Electron filling diagrams basically show where the electrons are or likely to be in an atom. Now I know that we've drawn Bohr models. In Bohr models we had a nucleus in the middle with electrons going around like planets orbiting the sun. But electron filling diagram kind of puts them all in a linear format, which you'll see in just a minute, and just kind of describes the electronic composition or electronic structure of the particular element. So a couple of definitions first, and these will make more sense once we actually start doing them. But Hund's rules, this is H-U-N-D-S, Hund's. So a lot of these names are going to sound kind of crazy because they were named for the German scientists that did work on these and came up with them. So Hund's rule, in my definition, I would say you fill them up before you double them. Now, like I said, I know this doesn't make sense right now, but it will in just a second. Off-ball principle, so that's A-U-F-B-A-U, off-ball principle. The off-ball principle says that electrons add in order of increasing energy. And the last one is by this guy named Wolfgang Pauli. So this is the Pauli exclusion principle, and this says that no two electrons can have the same set of quantum numbers. Now we'll talk about quantum numbers in a future video, but anyhow, for right now, just know that that's what this principle says, that no two electrons can have the same set of quantum numbers. So this long string of letters and numbers that I have here, this is actually or it says the off-ball principle, so let's kind of star this. This is basically the off-ball principle. This is the order of increasing energy for the levels and sublevels. Remember we said the principal energy level is designated by a number, and the orbital or subshells is designated by the letters. So normally this goes pretty swimmingly because we said that a 1 has one S, then the next has two S and two P, so there's a S and a P and a 2. And then 3S, and then 3P. But here it gets a little crazy. So you would normally think if we got 3S, 3P, the next one up would be a 3D. But actually, energy-wise, a 4S atomic orbital has less energy than a 3D. So according to the off-ball principle, this is the order in which we add everything. So we'll just use this as a reference when we're doing the electron filling diagrams. So let's go ahead and pick an element. So let's do magnesium. So magnesium is Mg, so magnesium has 12 electrons. So the electrons are what we're worried about with the electron filling diagram. We don't really need to concern ourselves with the neutrons or protons. We're just looking at the electrons. So magnesium, so with 12 electrons, I'm going to go ahead and start with this. We'll just go ahead and jump right in, and hopefully it'll make sense as we go on. So a 1s is the first energy level, and the first energy level has an S. Well, we know that an S can hold 2 electrons from a previous video. So I'm going to go ahead and draw them in with a half arrow going up and a half arrow going down. So each one of these arrows represents an electron. Now the reason why I'm not drawing a whole arrow like this is because when you get a bigger element and you're drawing in lots and lots of arrows, it just helps you save some time if you only draw a half arrow. When you finish, it almost looks like a chicken has danced across your paper, but that's fine. So the reason why we have one going up is because this denotes a positive spin on the electron, and the reason why we have an arrow going down is because this denotes a negative spin on the electron. So after a 1s, we know that a 1 doesn't have any more than an s, so we're going to put a 2s next. So we're just going in the order of the off-ball principle here. Okay, so this is what we need to concern ourselves with. So once again, an s can only hold 2 electrons, so I'll draw one up and one down. And after the 2s, we have a 2p. So we have a 2p. Now, if you recall, a p can hold 6 electrons. So that means it can hold 3 pairs of electrons. So I'm going to go ahead and put up, down, up, down, up, down. So now this gives me 2, 4, 6, 8, 10. I've got 10 electrons. Okay, so this gives me 10 total electrons. And after a 2p comes a 3s. So I'm going to say 3s here, and I'm going to draw one line. I'm going to have an arrow going up and an arrow going down. So now this gives me a total of 12. So 2, 4, 6, 8, 10, 12. So this is 12 electrons. So this is the orbital filling diagram for magnesium. Okay, so the orbital filling diagram is where you actually draw in the electrons. So this is the orbital filling diagram. So let's do another example. let's do, instead of magnesium, let's look at, let's do boron. So boron, actually, well, no, let's not do boron. Let's choose something a little bigger. Let's do oxygen. So oxygen has 8 electrons. So if we draw the electron or the electron filling diagram for oxygen, it would look like this. So we would do 1s, and then we would put our 2 electrons in, and then I would say 2s, and then I would put my 2 electrons in here also, and then after 2s, I have a 2p. So a p can hold up to 6 electrons, so I'll draw my 3 pairs. So I've got 2, 4, so I've got 4 more electrons that I need to put in. Okay, so I could say 1, 2, 3, 4. So this would give me my total number of electrons. If I had 2, 4, 6, 8. So you would think this would be okay, but this is actually incorrect. And the reason why this is incorrect is because we still have to follow Hund's rule. So I'll put another mark up here. So this is Hund's rule. Hund's rule says you have to fill them up before you double them up. Now the M here, fill them up, is the orbitals here. So before I can actually start doubling the electrons together, I must fill up each one of these dashes. So instead of this, I would have 2p, and I would have 4 electrons to put in. So I would go 1, 2, 3, and now that I've filled them up, I can start doubling them. So this is actually incorrect. So don't do this, okay? You actually have to fill them up before you double them up. So the correct electron filling diagram for oxygen would be 1s with these electrons, 2s with these electrons, and then this one down here, 2p, with 2 electrons here, 1 going up here, and 1 going up here. So this kind of concludes electron filling diagram. So if you just follow this, which is the off-bulb principle, and just add the electrons in, that'll be pretty easy for you.